practice continues on oxidation states. In the previous example, we were already finding who got oxidized, who got reduced, and for most of them, I think I was remarking on how many electrons were being transferred, whether the oxidation number changed by 1 or 2 or 6. That's what this question is about. So if you followed the previous example, there won't be too much new here. Let's see how it goes. Oxygen here, there are 4 of them, minus 2 each. That's a total of minus 8. The carbons must bring us up to negative 2, so there must be a total of plus 6 charge on the carbons, or plus 3 each. Over here, the oxygens are bringing a total of minus 4, so the carbon must be plus 4. You could say each, but that feels a little strange to say when there's only one atom. So, who changed? The oxygens were minus 2 each before and after. The carbon went from plus 3 each to plus 4. That means the carbon went up 1, which means it lost 1 electron. Each atom lost 1 electron. Electrons are negative, so getting rid of them means your charge goes up. Here we have minus 4 from our oxygen, so this nickel must be plus 4. And here, if you have a polyatomic ion like a hydroxide, you can just use its charge. That's a nice shortcut that saves you some time. Hydroxides have a charge of minus 1 each, so there's a total of minus 2 charge from the 2 hydroxides. That means this nickel must be plus 2. If nickel went from 4 down to 2, it was reduced, which means it must have gained electrons. How many? From 4 down to 2, they gain 2 electrons each. In chlorate, we have minus 6 charge from our oxygen, so the chlorine must be plus 5 here. And this chlorine is exactly what it looks like, minus 1. If you went from 5 all the way down to minus 1, that means you went down 6, which means you gained 6 negatively charged electrons. Oh boy, ethanol, plus 6 charge from our hydrogen, minus 2 from our oxygen. That puts us at plus 4. So the carbons must be minus 4 combined, or minus 2 each. Over on this side, the oxygens were minus 2 each, and so the carbon must be plus 4. Again, you could say each, but not really necessary with one atom. Carbon went from minus 2 up to plus 4. Its charge went up 6, which means it lost 6 electrons. What have we here? Oxygens, minus 2 each, total of minus 8. Hydrogen, plus 1. Sodium can only be plus 1, so we're getting plus 2 from those total. Plus 1 each, total of plus 2. Where does that put us? Minus 8 plus total of 3 is minus 5. This phosphorus must be plus 5. While over on the right, we're getting minus 4 from our oxygen, so we must be getting plus 4 from our phosphorus. The phosphorus went from plus 5 down to plus 4. It must have gained 1 electron, 1 negatively charged electron. N2O3, minus 6 charge from the oxygen, so the nitrogens must be plus 6 total, or plus 3 each. In ammonia, hydrogens are plus 1 each, so the nitrogen must be minus 3. So these nitrogens went from plus 3 each down to minus 3. That's a drop of 6, which means they must have each gained 6 electrons. Element X, xenon is Xe, so that's not what this is. This is just some made-up thing. We have 5 oxygens, minus 2 each. That's a total of minus 10. So element X must be plus 6. Over on this side, hydrogens are normally plus 1 each, so plus 3 total. To bring us back down to 0, the element X must be minus 3. Element X went from plus 6 all the way down to minus 3. That's a drop of 9. So it must have gained a whole truckload of electrons, 9 electrons. And this has got to be a capital M, or this doesn't make any sense. Potassium permanganate. So, -8 from the oxygen, +1 from the potassium. That brings us up to -7. This manganese must be worth +7, right? Because our total has to be 0. Over here, -2 each from the oxygens is -4. This manganese must be +4. And so the manganese went from +7 down to +4. That's a drop of 3. So the manganese gained 3 electrons.